Okay, hi, good day, everyone. So, before I start, let me first of all say that wisdom is the principal thing. Therefore, get wisdom, and in all thy getting, get understanding. So, this is another episode of Primary School Masterclass, the Caribbean's elite online educational academy. And today we will be doing a mathematics masterclass, and it will be a question isolate, meaning that we're going to focus on one question in particular, just one question. So this is going to be a short call, and yeah, we're going to ensure that we look at all the concepts and all the definitions and everything we need to know to really master this question 100%. Okay, so like I said before, this will be a mathematics masterclass. So let's look at the question isolate, just one question. And yes, this question was sent to me by one of my students via WhatsApp. She just took a picture of it. And gonna look at it right now. Okay. So the question says, which angle in the shape below is greater than a right angle? So it's a simple question. Okay, it most likely is going to appear in your section 2 in the SCA mathematics paper. So we're going to look at this question in detail. Let me read it one more time. Which angle in the shape below is greater than a right angle? So we have the shape below, and we have some lines, and of course we have A, B, C, or D. So those are our options. So let's look at the concepts and definitions before we do anything. So first of all, the question mentioned angle. It said greater than a right angle. So therefore we need to know our angles. So let's do our revision here. Now what is an angle? Well, the angle is the amount of turn between each arm. So if we see here, this is an example of an in no, this is an example of an angle. This is an angel. This is an angle. So just to clarify with the spelling here. Okay. So dealing with angles here. Okay. So the angle is the amount of turn between each arm. And we have the arm here. And we're going to look at the keywords amount of turn. Okay. So the amount of turn is called degrees. Okay. Right? So let me read that one more time. The angle is the amount of turn between each arm or each line or each side. Okay? And the amount of turn is called degrees. Okay? So these are some examples of angles at the SCA level. Okay? And there are different types of angles. So first of all, in the orange, we have a acute angle and acute angle. Okay? And we have a horizontal line, a sideways line, a line running from west to east, okay? And we have another line here, okay? So very important. Remember I said the amount of turn? Well, if you look there in this area here, you would see a arc. You would see an arc, okay? Now the arc is not really a big arc. It's a small arc, okay? And an acute angle always measures between 0 degrees, which is a sideways line, completely horizontal line, and 90 degrees, which is a perfect corner. Okay, and we were gonna look at this in detail when we look at the protractor graph, okay, which is coming up very shortly. Moving on, we have a right angle, and the right angle is one of, if not the most easiest angle to spot. It is a perfect corner, and it is seen one time. You can see this one time. You can identify it one time by seeing that square box there at the corner. That is a right angle. So once you see that, that is a right angle. Sometimes it's shaded, sometimes it's not, but that is always a right angle. And as shown here, right angles always measure exactly 90 degrees. Moving on to the pink, the obtuse angle. Now we could see here we have our horizontal line and another line pointing up. But the arc is much bigger than the arc we see in the acute angle. So the obtuse angle, you can see it passes 90 degrees, and obtuse angles are found between 90 degrees and 180 degrees. Okay, so that would be your obtuse angle. Moving on to the green, the straight angle. The straight angle is always a perfect straight line. It is always 180 degrees. And we could see the arc there is a perfect half circle, a perfect semicircle. Okay, so that will forever be the same. Okay, so a perfect straight line will always be 180 degrees. Moving on to a reflex angle. A reflex angle, you can see that the arc is very big. The arc is very big. It is past the acute, is bigger than the acute. It's bigger than the right angle. Okay. It is bigger than the obtuse angle, right? And it is bigger than the straight line. So that is called the reflex angle. And the reflex angle is between 180 degrees and 360 degrees. Okay? Now let's go on to a complete angle. A complete angle. A complete angle is a perfect circle, meaning it's, look at the arc, guys. It's always a perfect circle. It is a complete turn. Okay? Some people would say that it's 90 degrees times 4. Okay? So it makes one turn, two turns, three turns, four turns back to the beginning. So a complete angle is a circle and it's always 360 degrees. Okay? So these are the angles we need to know. Okay? So you can think about it like this. A right angle is always 90 degrees. A straight line is always 180 degrees. And a complete angle is always 360 degrees. Right? So look at those three there. Those three angles there always remain the same number. But the acute angle could fall between 0 to 90. Obtuse could fall between 90 to 180. And reflex could fall between 180 and 360. And we'll look at it practically using the protractor graph, right? So these are the concepts and definitions. So you are welcome to write this down as notes in your book. Let me just read it one more time. So number one, acute angles measure less than 90 degrees. Okay. Right angles always measure 90 degrees. And they are seen by the square box. Sometimes the square is shaded, sometimes it's not shaded. Once you see a square box there, it's a perfect corner, it's a perfect 90 degrees. Continuing, number three, a straight line always has 180 degrees. Perfect straight line, leveled off, always at 180 degrees. Number four, obtuse angles measure more than 90 degrees. So they are more than a right angle. Obtuse angles are more than a right angle, but are less than 180 degrees. Okay? Number five, reflex angles have more than 180 degrees and less than 360 degrees. Okay, so that would be your reflex angles. Continuing, number six, a circle always has 360 degrees. Can't run away from that. So that is the rule. Okay, so you guys can take a couple minutes and write this down in your book. Reasons for writing this down would be, when you write it down, you are reading it and writing it. So it becomes a part of you. Okay, you are really getting into the information. Don't just look at it on the screen, but add it and write it down into your mathematics notebook. Okay? And it's your handwriting. Okay? It's the way that you write. You could use colors. It is your book. So it becomes your note. So take a minute and write this down. Okay? You could pause the video at this time and do so. Okay? So when you're finished writing it down, we can continue here. So just a refresher of the question says, which angle in the shape below is greater than a right angle? Now what we want to look at now would be the things that we need to remember, okay? Now this question doesn't have a lot of working. There's no working actually, but we need to understand the concept of what is going on, okay? So these are some points that we need to remember. So number one, remember, you don't have to take this down, but you can if you want to. So just pause the video and do so now. Okay, right? But this would be a reminder, okay? So number one, remember that parallel lines are lines that never meet. They are always the same distance apart, okay? Parallel lines are lines that never meet. They are always the same distance apart. Number two, remember that a quadrilateral can be defined as a closed two-dimensional shape which has four straight sides. So we get in somewhere. So can you see two parallel lines? We can see two parallel lines here. A and B would be one line, and D and C would be the other line. So A and B are parallel to D and C. But A and B is parallel to D and C. So those would be your parallel lines. Also, this is a quadrilateral because there are four sides. It's a two-dimensional shape. Sorry, right? It's a two-dimensional shape which has four straight sides. So we do indeed have four straight sides. It is a quadrilateral. And quadrilateral, number three, remember a quadrilateral always has 360 degrees. A quadrilateral always has 360 degrees. Okay, so all these shapes here are going to add up to 360 degrees. Okay, and finally, remember that the shape seen is called a trapezium. Okay, it's called a trapezium. In the US and North America, especially, um, even up north, like Canada, the education system uses trapezoid, but it's the same thing. Okay, so sometimes you see trapezium, trapezoid when you're looking at different papers and questions. Okay, so a trapezium is a quadrilateral that has one pair of parallel lines. And we do indeed have just one pair of parallel lines. So if you ever wondered about it, this is called a trapezium or a trapezoid. Okay. Now, my favorite part, let's go to the charts. Let's go to the chart. Okay. So let me shift screen a little bit here. Wonderful. So I'm going to do a little bit of illustration here. Okay, using this website. Okay. It's kind of sticking on me here right now. Okay, let me do a refresher for the website. Okay, great. It's working now. Great. Wonderful. So guys, so this line here, I'm going to put it at 0 and I'm going to make different angles. So if I make a very small angle, let's say 1 degree or 0 degrees, you see 1 degree there. That's an acute angle. It's an angle between 0 and 90. This is an acute angle between 0 and 90. An acute angle between 0 and 90. If it's 44 degrees, it's acute. If it's 56 degrees, it's acute. If it's 67 degrees, it's acute. If it's 87 degrees, it's acute. But do you see how the arc is getting bigger? This area here. Do you see how that arc is getting bigger? So once that arc remains between 0 and 90, all these options here, I could drop it anywhere. It's always going to be an acute angle. Okay? However, the very moment I drop it here and I leave it at 90 degrees, okay, I am, well, this doesn't show, but in your books, in your questions, you would see a square or a corner here, okay, and that is a perfect corner. That is a perfect 90 degrees. So that is called a right angle. That is called a right angle. If I click it there, the name comes up, a right angle. But the minute I pull it back down, it becomes acute. Do you see that? All of these are acute. But if I put it on 90, boom, it becomes a right angle. Great. So we have an acute angle and a right angle. Now, if I increase from 90 and I go between 90 and 180, which is a straight line, and let's increase, see what's happening. It becomes obtuse. You see the name changes there? It becomes obtuse. So all these options, 116, 126, 143, 163, all these options say if I drop it anywhere between 90 at the right angle or 180, which is a straight line. Do you see the name there, guys? All of these options here are going to be called an obtuse angle. Okay, great. And you can see the arc is getting bigger, right? Arc is getting small. The arc is small for an acute. It's right angle there, okay, and it's getting bigger for the obtuse. Now for the straight line, 180 degrees is a perfect straight line, a perfect protractor, perfect semicircle, or perfect half circle. There is an instrument in your geometry set. If you know what a geometry set is, or if you're using it, you're definitely going to use it when you go into Form 1. It resembles this instrument here. It's a protractor, right? And the protractor shows me the different degrees I can use. That's 140 right there. That's 130. I'm reading it. Okay? So all these options here would be obtuse. So that's a perfect straight line. Oh, no, not yet. Okay, now it is 180 degrees. Wonderful. Now, if I increase from 180 or I pass 180, look what happens up here. It becomes reflex. So all these options here, it reflects. And do you see the size of the arc? Let me take away the protractor here. Do you see the size of the arc? See how big the arc is? When the arc is greater than 180, right? All of that is going to be reflex. All of this, if I drop it anywhere, guys, it's going to be reflex. 226, 293, 346. All of these options are reflex angles. And finally, if I bring it back home and I put it on 360 degrees, I have what you call a full angle. And if you look at my arc is now a perfect circle. A perfect circle, and a perfect circle always has 360 degrees exactly. Okay, so this would be the graphical presentation of our angles. So once again, acute, okay, we have acute angle. So this is a random option here. All right, so let me bring it back to 0. Oh, okay, I see what's going on. Good. So all of these angles here are acute. The minute I hit that 90 degrees, it's a right angle. Now it's obtuse. Once it passes the 180 degree mark, which is a straight line, it's reflex. And back to starting point, perfect 360 will be a circle. Will be a circle there. Okay. 360 full angle circle. So those are your angles practically explained there on graph. Okay. So now that we're coming back from the charts, Okay, from the diagram, that would be the diagram of the question. Okay, on the diagram, we see that there are two right angles shown by the corner square. Okay, let's go back to the question. There are two right angles. And if you guys look very carefully, the two right angles seen here are A and D. So we know those are 90-degree angles. Those are right angles. Continuing on, we need to look at B and C. There is one obtuse angle shown by the amount of turn. Okay, so let's look at the amount of turn. You see the amount of turn here? You see the amount of turn? You see how big that arc is? That is definitely not an acute angle, and it's greater than a right angle. So that is an obtuse angle. Okay, that is an obtuse angle. And C, do you see how small the amount of turn is? You see how small that arc is for C, right? That is going to be our acute angle, right? So on the diagram, we see that there are two right angles shown by the corner square, one obtuse angle, which is B, shown by the amount of turn, and one acute angle, which is C, shown by the amount of turn, right? So the question is, which angle in the shape below is greater than a right angle? And we know that the answer will be B. B would be the answer, and that angle would be an obtuse. Okay, so take away from this, remember, we can notice the amount of degrees on an angle by looking at the amount of turn. Okay, the shape or how big the arc is between the angles. Okay, and trying to keep this video as short and sweet as possible. This has been Mathematics Masterclass, adding to life. If you would like one-on-one lessons for mathematics to be part on one-on-one classes, you can use this contact information here. Even if you choose another subject one-on-one, there will also be supporting mathematics classes done every Saturday. So you basically get an mathematics masterclass in focus, creative writing, and of course, English language. So have a blessed day. I hope that this was helpful. God bless everyone looking at this video and have a great day. Bye.